Number 3, consider the finite sequence of numbers. Verify the ratio of each term to the previous is a constant. It's just a quick verification. All you need to do is to say u2 divided by u1, u3 divided by u2, u4 divided by u3, u5 divided by u4, all are the same. Verify, no problem. So you have 1, 2, 3, 4, 5 terms. Here 1, 2, 3, 4, 5. No problem. Okay, all verified. Okay, ratio of each term to the previous. Now, here, therefore, we can safely say that first term is 81. Alright, R is negative 1/3. Alright, and UN is 81 negative 1/3 to the power of n minus 1. Now, I must emphasize this. This is a finite sequence. That means all we are saying is these 5 terms follow a GP. That's all we are saying. We're not saying that it will continue. Because the question says it's a finite sequence. It's only 5 terms. And these 5 terms clearly follow a GP. That's all we're saying. Okay? Follow so far? Okay? Any questions? Okay, good. Okay, let's carry on. Yeah, why like that? Example 4. Okay, very quickly, tell me from observation. Look at this, look at part A. From observation, our first term A is what? 3, of course. R is 2, very good. Quite easy lah. To find n, now what do we want us to do? You want to find the number of terms n. Why do we need to find the number of terms? How do we find it? Because this is first term, second term, third term. 1, 5, 3, 6 is which term? That's what you want to find. Is it the 200 term or is it the 100 term? I don't know. You want to find out. So making use of this idea, the nth term is ARn minus 1. You make use of that. Alright? By saying this. Since UN is 1, 5, 3, 6. So, therefore, 3 times 2 to the power of n minus 1 equals to 1, 5, 3, 6. What you then do is one equation, one unknown. You can easily solve. You divide both sides by 1, 5, 3, 6. You get 5, 1, 2, which you can observe that it is 2 to the power of 9. Now, I'm not asking you that to observe that 5, 1, 2 is 2 to the power of 9. If you know, well and good. If you don't know, how do you solve? If you don't know this, how do you solve? You tell me? Huh? Log 2, yes. You take log on both sides. Follow what I'm saying? Then you realize, even by calculator, you realize that n is a very nice number. Do you need me to show you? Now, if you don't know, if you can't observe this, if you don't know 5, 1, 2 is equals to 2 to the power of 9, what happens? You will say 2n minus 1 equals to 5, 1, 2. How do you solve? How do you solve this? Then you take log on both sides. Take log, whatever. Alright, you take log 2. Then n minus 1 equals to log 5, 1, 2 over log 2. N equals to 10. You will still get the same thing. You realize that your calculator will give you a very nice number here. The calculator will give you 9 here. Log 5, 1, 2 over log 2. Follow? Okay? You can't observe it. Okay? Question? All good. Now next. Similarly, you can observe that B, what is the R? Look here. What's the common ratio? 3 square, very good. So now, therefore, we can say 3 first term times 3 square to the power of n minus 1 is equals to 329. And now they are quite kind, they give you 3 to the power 29. This one you can easily solve, this one no need to take log anymore. They are quite kind. So now you practice your laws of integers. You combine this 2n minus 2 plus 1, then you get 2n minus 1. Correct? Times these are laws of integers, don't forget, okay? Can? Alright, then you get 2n minus 1, then you compare, you realize that 2n minus 1 is 59, and it goes 55. Easy, easy. Question? No question, we move on, eh? Easy one, we move faster lah. Oh, can? Example 5. Given that these 5 terms are consecutive terms of a GP. Okay? Now you need to find A1, A2, A3. A1, A2, and A3. So now, if they are consecutives of terms of a GP, we can say, assuming that now that first term is 2, 4, 3. First term is 2, 4, 3. Then this is the second term, this is the third term, this is the fourth term, this is the fifth term. No problem. Okay? Alright? Then, what do we do? If, look, this is the first term, then this should be the second, third, fourth, this is the fifth term. Correct? Correct? If the first term is the fifth term, we can easily say that fifth term is actually AR to the power of 4. AR by n minus 1. Right? You are using this formula again. Okay? So only one equation one I know now, this is 48. This is 2 more 3 to the power of 4. So you only have one equation one I know that is R is only unknown. Right? Then we solve. So R4 must be equals to, we divide 2, 4, 3, 48 divided by 2, 4, 3, you realize that this is 16 over 81. Or you take 48 divided by 2, 4, 3, you get this. Now can you tell me what is the solution for R? R to the power of 4 is 16 over 81. Plus minus, okay? You cannot just put plus to the way. This is R to the power of 4. Follow? You know why? No, so don't just include the positive. It actually, there are 2 solutions. It is plus minus 2/3. Can see, you need to use a thicker pen like this one. Here. Better. Or a different color, whatever lah. Can see, can already. Okay. Now, what do we want to find? We actually want to find A1, A2, A3. Once you get R, actually it's quite easy. If you have R is 2/3, then you find A1, A2, A3. If R is negative 2/3, you're right on your own, Ken. You're right on your own. Just apply the same thing. So A1 equals to 2, 4, 3, negative 2/3. About 1 equals to negative 162. You complete on your own. You complete the rest on your own, okay? Okay? Right, too easy, right? You move faster, right? Well. Huh? You move faster, right? Oh, okay, it's so easy, Oh. Okay, now 4.2, showing that sequence is geometric. Now, I don't know whether you recall. I don't know whether you recall for AP. How do we show that an AP, a sequence is an AP? How do we show? To show sequence is an AP. How do we use to do it? Equals to a constant. Very good. That means what you are saying is no matter what is n, for general term, no matter what is n, the term minus away the term before it will always be a constant, independent of n. Follow what I'm saying? Now, how to show sequence is GP. I think you get the same idea. What do you do? Say again. Divide. Because this AP, the pattern of AP is add a constant number, right? Add, say this one is S3, right? So, but then for GP, it's multiply. So in order to show that a sequence is an GP, divide. Tn divided by Tn minus 1, or we say Un over Dy minus 1, doesn't matter, equals to a constant. Can follow what I'm saying? So, here, the idea is here. For all values of n. Okay, example 6. Must read the question carefully, okay? Later I can show you a typical exam question for APGP. It's quite interesting. What your seniors just took for their CT1 paper. I'll show you. Quite fun. Okay? Okay? I think after we learn the sum, after we haven't learned sum, cannot do. But later I show you. Okay, I show you. Anyway, this is Sn. Sum of the first n terms of a series, alright, is this. By finding the expression for the nth term, show that the sequence is geometric and state the values of the first term and the common ratio. So, again, I must stress this relationship is true for all sequence. Or, this is a series, right? This is a series, right? Alright? This one minus this, no matter what is S, correct? It is always true. The nth term is always like that. Okay? Whether it's if you don't know what is it, you always will apply it. Therefore, this is 2, 3n minus 1 minus 2, 3n minus 1 minus 1. You do the simplification, you realize that the 2 and the 2 goes, then you are left with this. You factorize the 2, not factorize, I think you factorize the 2, yes. Yeah. And or you factorize this one out. You understand? You factorize this guy out. You factorize this term out of. You factorize this one out of itself, you get 1. You factorize this term out of this, you are left with the 3. Okay? Alright? No matter how you do it, you get something like that. Question? Can? Okay. Now this is the nth term. This is the nth. Oops. Now to show that it is a GP, what you do is un plus 1 divided by un. Un plus 1 divided by un. Therefore, this is un plus 1 is this. Divide by this. If this cancel, then you realize it's 3. You are very sure that it is a GP. Done. Any questions? All okay? Can? Then what do they want us to do? State the value of the first term and the common ratio. Now this is quite obvious. This is the common ratio. Okay? This is quite obvious, is the common ratio. Now the first term is just S1. Correct? S1 is sum to first term is actually the same as A. Substitute it, you get 4, common ratio 3, you're done. Correct? I won't even bother about this one. I would rather use, this one. I prefer to use this. Right, because this won't go wrong. A is just for S1. Rather than go around that way and then you try and say what is U1 and try and find out. Obviously you can do it, but not really necessary. Okay? Alright. Now we try and prove the sum now. Okay? Remember how we prove the sum for AB? Quite interesting, right? You all remember? We write it in the reverse direction and then add the two up. Correct? Now how do you prove for GP? It's a different method, but it's also quite fun. Okay, without looking at your notes, let's go through it together. Without looking at your notes, because you will see your notes, you will get an answer already. Now Sn equals to A plus AR plus AR squared all the way to AR n minus 1. Agree? Agree? So what's good? Now if I multiply both sides by R, what do I get? I'll get AR plus AR squared plus all the way to AR n. I deliberately write it like that so that you can see pattern. Because the first term now will be AR, then AR squared, and then the last term now is AR n because you multiply by R already. Follow so far? I think you get the answer now. What you see is, maybe I should write it like that. Like that, easier for you to see. Okay? This is the last two terms. What you do, you minus. You take this, minus this. 1 minus R, what is n? What do you get? The A minus AR. And therefore, Sn is A 1 minus Rn over 1 minus R. Done. That's how you prove it. Or this is the final result. Question? Yes. Oh. Which part do you not get it? This one, okay. This one, okay. This is equation 1. This one, so this is equation 1 times R. Okay? Then you get equation 2. What I do is equation 1 minus equation 2. Okay? Equation 1 minus equation 2, your left hand side, this one minus this one, you get this. Right side, this minus this, what do you get? This, all the terms are the same. All the terms are the same. Cancel, you get this minus this. Okay. Therefore, Sn, which is the sum to n terms, is the formula like that. Alright? Okay? So we can safely use this without proof. We can use this without proof. Okay? Oh, sorry. All here already. Yeah. Didn't know. Okay. Anyways, you all complete this one all by yourself. Right. Copy. I erase this. Then you copy. Do it all by yourself. Do. Okay. Hey, go on. You right. Minus lah. Okay. Actually, I wanted you all to write out lah. That means this, right? This is A plus AR squared plus AR n minus 2 plus AR n minus 1 minus away. AR plus AR squared plus. then you realize that this one cancel, 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 cancel. Correct? You realize that, you see that? Now this formula only works. This formula only works if R is not equals to 1. Correct? Quite obvious. Because if R equals to 1, what happens to your denominator? Here, if R equals to 1, your denominator here is 0. So, what happens if R equals to 1? Do you all know? What happens if R equals to 1? Then what formula do you use? What formula do you use when R equals to 1? This formula now? No need lah, it's all the same term lah. A lah, this formula for what? What are they? Oh, okay. Done. So actually, I don't need to teach anymore because you all know everything. You know n term for AP and GP. You know sum the n terms for AP and GP. Actually, I now can show you the exam question. Actually personally, I tell you honestly, your exam will have won't have this kind of what I call pure math questions. That means only see numbers and symbols. They will always tell you story. So I show you a story, can? Show you a story. This one. This is their senior CT1 paper. You all want, you take a picture. I'm not going to solve it now, okay? You all read and get a flavor of it. You all want to take a picture, go back and solve on your own. You see lah. You want to take a picture, okay? So it's not going to be about the symbols, what I see, find instant. Increasingly, A-level trend is to tell you a story. Okay, and then you interpret the story, use what you learn, and you solve it. Just give you a flavor of what is to come. Especially, I can tell you, especially for your new syllabus. Especially for your new syllabus. This year 2016 syllabus. Yeah, your H2 is a different syllabus from your seniors. Yes, actually it's better in the sense that there are some topics that are removed, but then the trend is to incorporate this type of questions rather than the one term just using symbol. Okay? Any idea? Got idea how to solve? Roughly. Oh. I'm not Mr. Wong. This one is Mr. Wong. Yeah, it's okay. No, this A we are talking about is 8%. 8% there. So don't assume that this is always the first term. You're talking about 8% there. Okay? Okay? Interesting, right? Okay. Let's move on. Huh? Haven't you? Oh, okay. Read. Send to the classroom. Very good. I can give you an answer for you to check. I think this one should be 2.35 if I'm not wrong. The answer, final answer is 2.35. I think. I can check. Okay, 2.35. Okay? Okay, good. Let's move on. Example 7. Use an algebraic method. Find a set of values for which this is greater than 2000. Now, okay, Ken? First, recognize there is a GP. How do we know it's a GP? Actually, it's not difficult, but it's a lot easier if you write out the terms. Maybe you start R equals to 1, you get this, R equals to 2, you get this, R equals to 3, you get that. It's not obvious, it's now a GP. First term is 5, right? Common ratio is 3. Done. Quite obvious. First term 5, common ratio 3. Alright? So, now this, in actual fact, this is a sum to n terms. We must be very careful that this is n. Sorry, this one should be. This is r equals to 1, right? Be careful, don't assume that this is to n terms, but it so happens that it's from 1 and therefore it's sum to n terms. You use the formula sum to n terms. If this is n minus 1, then you better change accordingly. You follow what I'm saying? Or this sum to n terms. Now, so we apply the formula. We get a 1 minus r to the power of n minus 1, oops, over 1 minus r greater than 2000. Okay? Correct or not? Why you all look at me like that? I'm very scared. Oh, sorry, n. Sorry. N. Okay, a 1 minus r to the power n divided by 1 minus r. Okay? Then you realize that actually one, you take 1 minus 3, you take 3 minus 1, you multiply top and bottom by -1. Then you divide both sides by 5, you get 400 here, yes. Alright? Then you multiply both sides by 2, you get 800. Then how do you solve? This one no choice because it's not a very nice number, you have to use log. Okay? Now I want to say this. When you take log or take ln, what happens is, do you swap the inequality sign when you take ln or take log? No. Okay. When do you swap the inequality sign? When it's negative. Okay, let's continue with this and then I give you another example to see what you all know how to solve. N is greater than so therefore the set of values is okay? This one quite clear cut, we know how to solve, there's no problem. Can I ask you, what if I want you to solve, say, possible or not? No lah, not possible lah. One more time. 2 to the power of n is greater than 0.5. How do you solve? Take log. Take log. Do we solve the inequality sign here? No. Some say yes, some say no. Swap. Solve. Don't solve. Okay, you all may find out. Tell me the final answer and then you decide whether you solve or not solve. You all do in your groups. Some say solve, some say no solve. Tell me final answer first, then you decide whether you solve or not solve. First, you discuss when do you solve. First, you discuss when you solve. When you switch the inequality. You only switch. You all discuss inside in your groups, so you tell me. Don't tell me. You all discuss in your groups. You all have a consensus. Try and find a consensus. If you solve once you got that clear, then you discuss that one. So anyone, all the groups okay? Consensus? All blur. Don't know what I'm asking. No, I'm asking. No, right? The big question you gotta ask yourself is not about negative and positive yet. The big question you gotta ask yourself is when you take ln on both sides, or do an exact operation on left and right, do you solve the inequality sign? Don't say so fast yet. It depends. It depends. Now I tell you. If I tell you 2 is greater than 1.5. 2 is greater than 1.5. Huh? Is log 2 greater than log 1.5? Yes. So log 2 is greater than log 1.5. So do you solve inequality sign? You don't. Correct? You don't, huh? So now, if I say 0.5 larger than 0.3, you take log 0.5 and log 0.3, which is larger? 0.5 is still larger. So do you solve inequality sign? You still don't. So it's not with the numbers. Now you have to discuss your log graph. Is it increasing function or decreasing function throughout? If it's always an increasing function, then if you have A bigger than B, then log A will always be bigger than log B. If you take log on both sides, you will never solve inequality sign. Do you follow what I'm saying? If log is an increasing function, which it is, of course, for all x greater than 0, log is an increasing function. So this will always apply A greater than B, then log A must always be greater than log B. For sure, because log is an increasing function. So I come back to this question. Then we say, oh, okay, we take log, no problem. It's an increasing function, you get this. Alright? Then we are done. Correct? Then all you need to do now is to bring the n down, power law, and then divide both sides by log 2. At this point, you got to ask yourself, when you divide by log 2, is log 2 a positive number or a negative number? If it's a positive number, then your sign should be made. Do you follow what I'm saying? So now it's log. This sign should be made, should not be. Now, but had this been a negative number, if this thing had been a negative number, then you got to swap at that point. So there are two decision points to make, you know. One is when you take log, which is an increasing function, you don't swap at all. Because log is an increasing function. Do you follow me? Then we go back to that question. Go back to this one. Let's look at this, cosine. How do you solve this? Sorry? Actually true. Actually true. First you have to recognize that theta is between 0 to pi over 2. Between 0 to pi over 2 is a decreasing function. You've got to sketch the graph to tell me that this is half. If you want cosine theta to be bigger than half, you actually want this part. So, which means your theta must be less than your pi over. And of course, because of this, so there is a less than not bigger than. But if you didn't sketch the graph and you didn't spot that it's a decreasing function, you wouldn't have gotten this. You follow what I'm saying? Cosine is a decreasing function from 0 to pi. You follow what I'm saying? Oh, so be careful in solving inequalities. Be very careful in solving inequalities. So this one is quite a clear-cut example, there's no problem. Okay, example 8. This is a kind that getting more and more exam-like, this kind of question. Read the question carefully. A man deposits $5,000 at the beginning of a year that gives 4% interest. Ready? 4% interest, So, it's compounded. At the end of first year, you get 5,000. All agree. This is we're talking about at the end of the year, you get 5,000 times 1.04. No problem. End of 2 years, end of 2 years is this amount. This is the amount at the start of the second year that will be compounded on the second year. This one must times 1.04. Follow again? Follow? At the third year, I think this is the amount that is at the end of the second year. This is the amount, same amount at the start of the third year. And the third year compound interest times 1.04. I think you all see the pattern. So, look carefully. First year to the power of 1. Second year to the power of 2. Third year to the power of 3. 10th year to the power of 10. Done. Okay. This one is a very typical. Go and study this. Better make sure you know how to do this, okay? It's a very typical exam problem. Okay? That first one too easy. Example 8 will never come out in exam. Never. Tell you. Never. Example 9 easy. Okay? What happens is this. He deposits 5,000 and for each year into the bank account, that gives 4%. Then he doesn't need to withdraw. So first year he puts 5,000, second year another 5,000, third year another 5,000. So he keeps putting it around. How much would there be at the end of 1 year, 2 years, 3 years? It's a bit more confusing because at the end of 10 years, he would have put in a lot of $5,000, and that $5,000 will earn different interest. You follow what I'm saying? Okay? Disgusting, why? Okay? So, first year very easy. I want to say this technique of the table very important. Okay, if you draft a good table, you can see pattern quite fast. If you don't do a good table, then you can't see pattern. Now, first year very easy because you only put 5,000, and at the end of the first year you earn 5,000. Now, second year, what happens? Second year is not so clear cut because at the start of the second year, actually you have this one, but you not only have this because at the start of every year you put 5,000 in. So when you spot pattern, I want to say this, you don't write 5,000 in here. You will write 5,000 times 1.04 so that it's easier for you to spot pattern. You don't evaluate it out. So what we will do is, first, you have the 5,000 that you put in at the beginning of each year. This is the 5,000 plus the 5,000 times 1.04. This is the balance. This is the balance from here. So far so good. So far so good. Now, then this amount is going to be compounded at this is the start of the second year. At the end of the second year, this amount you are going to times 1.04. Correct? So again, I suggest you don't evaluate out. You will write it like that. Sorry, maybe I should have. Okay, you all don't need to change. I just want to. Actually, it's this like that is clearer. I just swap the terms around, but never mind, it's okay because of here lah. Never mind, it's okay, no big deal. So this one is 5,000 times 1.04 plus 5,000 close bracket, times another 1.04. Because this amount is compounded by 1.04 for a second. Of course, the question asks us to evaluate this amount, but we've got to keep this pattern here. Because you say 5,000 times 1.04, you can have 5,000 times 1.04. 5,000 times 1.04 times 1.04, you get a square. Do you all follow the pattern so far? Do you all follow the pattern so far? Sure? Can follow? Because eventually you're going to stop pattern at 10 years, and you're not going to do it manually for 10 years, right? Okay? This is the pattern I'm looking out for later. This one is super important. Never mind, cannot see, never mind. We try third year. Third year goes like this. This one, I'm going to copy and paste this because this is the end of second year. 5,000 times 1.04 square plus 1.04 plus 5,000. This one is what you put in at the start of the third year. This one is the balance from the second year. Then you take this, multiply by 1.04, you get here. And then you realize that you will see another nice pattern. Follow what I'm saying? Okay? So, you compound it, get 5,000. Alright? This amount, they say that, oh, actually, there's some pattern. There is 5,000 times 1.04, this 5,000 times 1.04, and then you have a square, 1.04 square, and then 1.04 square times this per cube. Nice. This is the pattern that I'm looking out for again. Your exact reaction, your reaction is exactly like a typical student when you see this kind of question, because it gets a bit confusing and frustrating. But no choice. This is the type of question that can come up. Always, I can tell you. I can search 10 series, I can tell you a lot of this kind of question. So, are we able to write for 10 years? Now you see, for 2 years is this, for 3 years is this. Actually, it's so easy to write 10 years because once you do this part well, this one is easy. Follow what I'm saying? If you do the first two parts well, you see the highlighted portion, you can spot pattern. Alright? And I think it's not difficult. Now, you have 5,000. What should it be in the brackets? If it's 3, then you end up with 3. If it's 2, 2. Then this one must be 1.04 to about 10 times plus 1.049 all the way to 1.04. Done. Now, we should be able to then recognize that this is a nice GP. Whether you see it like this way or this way, up to you. Of course, most of us will see it as GP this way, correct? R is 1.04. Number of terms, be very careful. 1, 2, 3, all the way to 10. Okay, yes, this is quite clear cut, 10 terms. So therefore, you use the formula. First term is this. First term A. 1 minus R to the power of n divided by 1 minus R. Done. This is the sum to GP formula. Correct? Yes? Yes. Yes, you do have to memorize this formula. Or you can prove it on the spot to yourself. Actually, it's not fast. Yeah, yeah. Why is there? This is the first term. This one, Oh no, 5,000 I factorized out already. Okay, actually you can see in many ways. You can say 5,000 I factorized, now factorize out, then it's 5,000. Or you can say the first term is 5,000 times 1.04, first term is 5,000. Either way you see, you definitely have this. Follow? Okay? Right? Do you understand? You understand? Okay, you explain to us. Okay, then we are done. Okay, time's up. See you very soon. Wow. Okay, never mind. See you on Thursday. We should finish on Thursday. Yeah, I think Thursday we may need the whole period. Okay, can done.